Welcome to The Explainer. We have machines that heat our homes and completely separate machines that cool them down. But what if I told you there's a device that does both? A single machine that can act like a furnace in the winter and an air conditioner in the summer. The secret? It doesn't actually create heat, it just moves it. And understanding that one simple trick is absolutely key to unlocking the future of energy efficiency. So let's break it down. So here's our game plan for today. We'll start with the big idea, then we'll meet the key players inside the machine. We're going to follow the incredible journey of heat as it's pulled from the cold outside air, and then watch how the system flips a switch to start cooling things down. And finally, we'll talk about why this whole process is such a big deal. All right, let's dive right in with that central idea. Really think about that for a second. A furnace and an air conditioner feel like complete opposites, right? One makes things hot, the other makes things cold. So how on earth can one box do both jobs? Well, the secret isn't magic. It's not about making heat from nothing. It's about being incredibly clever with the heat that's already all around us. Yes, even on a freezing cold day. And this isn't some brand new futuristic tech. It's actually hidden in plain sight. If you've ever been to a big university campus, a modern hospital, or even just your local shopping mall, you have almost certainly been kept comfortable by a giant heat pump system. They're already everywhere. Now, the whole setup is really a team of two. First, you've got the heat pump itself. Think of that as the engine. It's usually outside, and it's doing the really hard thermodynamic work with a special fluid called a refrigerant. Its job is to create super hot or super cold water. Then you've got the delivery service inside, the Fan-Coil unit. Its job is way simpler. It just uses a fan to blow your room's air over pipes filled with that hot or cold water, so you get warm or cool air. Two different parts, one seamless system. Okay, so how does that engine actually work its magic? To figure that out, we've got to pop the hood and meet the key components at the heart of the system. If you remember one thing from this explainer, make it this: the four-way reversing valve. This little piece is the absolute hero of our story. It's basically the traffic cop for the whole system. With just one signal, it completely flips the direction the refrigerant is flowing. And that one simple action is what lets the machine switch from heating to cooling. It's the brain of the whole operation. And our traffic cop directs the refrigerant on a four-stop journey. It goes through a compressor to get squeezed, a condenser to release heat, an expansion valve to get a massive pressure drop, and an evaporator to soak up heat. These four parts make up the core cycle. Let's follow the flow. First up, let's trace the heating cycle. Now, this is the part that feels a little like science fiction, because we're going to see how the system literally pulls heat out of the cold winter air to make your room toasty warm. Okay, so it all starts at the compressor. It takes in a cool refrigerant gas and squeezes it hard. Basic physics tells us when you compress a gas, it gets super hot. This hot gas now travels to the indoor unit, which acts as a condenser. All that heat gets released into the water for your fan coil, warming up your room. As it loses its heat, the gas turns into a warm liquid. That liquid then gets forced through a tiny little opening in the expansion valve. It's like letting air out of a tire. The pressure and temperature instantly plummet, and now you have a freezing cold liquid. And here's the genius part. That freezing liquid gets sent outside. Because it is so much colder than the winter air, it actually absorbs heat from the cold air around it, turning back into a cool gas, ready to go back to the compressor and start the whole trip over again. Wild, right? Okay, so that's heating, an amazing process. But what about when summer comes? How does this same machine cool your room down? Well, this is where our little traffic cop comes back into the picture. Remember that four-way reversing valve? It flips. That's it. It just changes the path of the refrigerant. So now that super hot gas coming out of the compressor, instead of being sent inside to warm you up, it gets routed straight to the outdoor unit. The entire system is now running in reverse. This one simple change means the indoor and outdoor units completely swap jobs. The unit inside your building is no longer a condenser releasing heat. It becomes an evaporator, absorbing heat from your room and making it feel cool. And the outdoor unit, well, it's now the condenser, taking all that heat from your room and releasing it into the outside air. It's the exact same hardware, doing the exact same jobs, just in opposite places. It's an incredibly elegant solution. So that's the beautiful theory of how it all works. But of course, the real world is a little messier than a textbook diagram. To make sure these machines run efficiently and last for decades, engineers have a couple of crucial tricks up their sleeves. See, in a perfect world, the refrigerant arriving at the compressor would be 100% gas, and the refrigerant hitting the expansion valve would be 100% liquid. But reality isn't perfect, and engineers don't take chances, so they add in some safety margins. They make sure the vapor is a little bit hotter than it needs to be, that's called superheating, and they make the liquid a little colder than it needs to be, that's subcooling. And the reasons for this are really simple: protection and performance. A compressor is designed to compress gas. Trying to compress even a tiny droplet of liquid could literally destroy it. So superheating is an insurance policy to make sure only pure gas gets in. On the other side, the expansion valve works most efficiently with pure liquid. If any gas bubbles get in there, you lose performance. So subcooling makes sure it gets a solid stream of liquid for maximum cooling power. These aren't just minor details. They're what make the system tough and reliable. So, when you put all of this together, when you step back and look at the whole picture, you realize the single most important idea behind this technology. The future of climate control isn't about making heat, it's about moving it. And that right there is the big takeaway. Think about a standard electric heater. It's basically a giant toaster. It uses a ton of electricity to create heat from scratch. A heat pump doesn't do that. It just uses a smaller amount of electricity to power the components that move existing heat from one place to another. And because moving something takes way less energy than creating it, the process is incredibly efficient. We're talking about putting in 1 unit of electrical energy and getting 3, 4, or even 5 units of heat energy in return. That's a game changer. Which leaves us with a final, pretty important question. In a world that's desperately searching for smarter, more efficient ways to use energy, is this simple thermodynamic trick, just moving heat instead of making it, the real key to designing our future? It's a powerful idea, and it's one that might just change the way we all live. Thanks for joining us.